In this video, we introduce SituationAdapt, an end-to-end system that considers social and environmental aspects to adapt mixed reality user interfaces to shared physical spaces. Mixed reality is increasingly used in mobile settings beyond controlled home and office spaces. Unlike user interfaces on traditional screen devices such as laptops, mixed reality user interfaces transcend device boundaries and can seamlessly blend into the user's physical surroundings by overlaying part of the real world. However, existing adaptive systems are designed for static environments and cannot adapt to the varying contexts of shared spaces. For instance, in this scenario, the mixed reality layout is adapted to align interactive widgets with surfaces, yet it does not consider that the monitor in the background displays information relevant to the user. Similarly, it places a widget in front of the face of a classmate, not considering that he is talking with the user. To tackle this challenge, we propose SituationAdapt. In the same scenario, our system recognizes the monitor in the background and adapts the mixed reality layout to stay clear of the video playback. It also detects that the classmate is initiating a conversation with the user and ensures that no widget obstructs his face. Our system consists of 3 modules for perception, reasoning, and optimization. The perception module recognizes objects and people around the user and fits 2D and 3D bounding boxes around them. Our reasoning module leverages a vision and language model to evaluate the suitability of scene locations to accommodate UI elements for display or interaction. Our optimization scheme then uses these ratings as well as the 3D bounding boxes as input and generates mixed reality interfaces, ensuring that widgets do not obstruct relevant real-world cues or interfere with social norms. In a crowdsourced online survey, we validate if our reasoning module judges the context of shared spaces similar to experienced MR users. The results of the survey indicate that, across scenarios, VLMs achieved comparable ratings to participants for both overlay and interaction suitability. We conducted a user study to compare SituationAdapt's optimized layouts with those of 2 baseline methods in a lecture setting. User-centric places elements in a sphere around the user comparable to interfaces of commercial mixed reality headsets. SurfaceAdapt prioritizes placement of elements on surfaces similar to existing methods that align layouts with physical surfaces to facilitate interaction. SituationAdapt represents our system's output, optimizing layouts according to the situational context in the seminar room. Participants perceived SituationAdapt's MR layouts to more suitably overlay UI elements onto the physical environment and position them more appropriately for interaction. Participants also expressed a strong preference for the layouts generated by SituationAdapt compared to those from baseline methods. In this scenario, the user takes a break from work and is having lunch. While eating, he watches sports videos through a virtual browser. After a while, the user's colleague comes to the table, activates the laptop, and starts a chat with the user. Our system detects that the colleague is initiating a conversation with the user and that the laptop is turned on and dynamically adjusts the layout of virtual elements. All virtual elements are now repositioned away from the colleague and prevented from overlaying the laptop, ensuring the content under discussion remains unobstructed. Within this context, the user first browses groceries, online recipes, and cooking videos at his desk, aligning the virtual elements with its surface. Transitioning to the kitchen and putting on the headset again, he discovers his previously designed layout to include kitchen utensils as well as a warning sign on the wall. Our system identifies the respective objects and changes the layout to keep the virtual elements visible and prevent occlusion of warning sign, knife, and plate.